In land navigation, understanding the lay of the land is just as important as knowing your direction. One of the most powerful tools for interpreting terrain is the contour line, a simple yet detailed representation of elevation on a topographic map. These lines allow navigators to visualize hills, valleys, ridges, and slopes without ever stepping foot on the ground. Before setting out on any journey through unfamiliar terrain, it's essential to grasp how contour lines work, what they reveal about the landscape, and how they can guide your decisions in the field. In this video, we'll explore how to read and interpret contour lines to enhance your situational awareness and navigation skills. Contour lines are the most common way to show the shape and elevation of the land. A contour line is a brown line on a map that represents an imaginary line on the ground, above or below a specific reference elevation, usually sea level, where every point along that line has the same elevation. In other words, if you were to walk along a contour line in real life, you would stay at a consistent height the entire time. These lines help us visualize the vertical distance between different parts of the terrain, such as slopes, depressions, ridges, cliffs, and other topographical features. They provide a useful tool to understand the shape and elevation of the land without leaving the map. As we begin to explore topographic maps, it's important to understand the three main types of contour lines that help us interpret elevation and terrain. First, we have index contour lines. These are the bold or darker lines that appear every fifth line on a map. At some point along an index line, you can see a label showing the elevation, which makes it easier to identify the land's height and use them as reference points. A line marked 425, for example, means that point on the map is 425 feet above sea level. Between each index line, you'll find intermediate contour lines. These are thinner and more subtle, and they lack elevation labels. Usually, there are 4 intermediate lines between each index line, helping to illustrate gradual changes in elevation. Lastly, in areas where elevation changes are minimal, supplementary contour lines are used to provide greater detail to the terrain. These lines typically appear as dashed or thin continuous lines without labeled elevation values and represent elevation changes of at least half the standard contour interval. They are especially useful in relatively flat regions where the normal contour interval may be too large to capture subtle but significant changes in elevation. By adding these half-interval contours, maps offer a more accurate and nuanced depiction of the landscape, enhancing a navigator's ability to interpret terrain and plan routes with confidence and precision. The specific interval used for supplementary contours is usually noted in the map's contour interval legend. Now that we've explored the different types of contour lines and how they represent various terrain features, it's time to shift our focus to how we actually read and interpret these lines on a map. Understanding the spacing, shape, and patterns of contour lines is key to visualizing the landscape and making informed decisions while navigating. In the next section, we'll break down the techniques for reading contour lines and explain how to use them to assess elevation changes, identify landforms, and plan effective routes. Before we dive into reading contour line characteristics, it's important to understand the concept of contour intervals. A contour interval is the vertical distance or difference in elevation between two adjacent contour lines on a map. This value is consistent throughout the map and is usually noted in the map legend. For example, if the contour interval is 20 feet, each line represents a 20-foot change in elevation from the one next to it. This helps us measure how steep or gentle a slope is just by looking at the spacing between the lines. Smaller contour intervals are used in flatter areas to show subtle changes in elevation, while larger intervals are used in mountainous regions to avoid cluttering the map. By interpreting the contour lines and considering the contour interval, navigators can assess the steepness of slopes, identify high and low points, understand the general topography of an area, and plan routes or activities accordingly. Now that we understand contour intervals, let's take a closer look at how the shape and spacing of contour lines reveal specific terrain features. When reading a topographic map, contour lines reveal the shape and steepness of the terrain. Let's break down what different contour patterns tell us. First, concentric circles of contour lines indicate a hill, with each ring representing an increase in elevation as you move inward. The inside of the smallest closed circle is the hilltop. If those lines are evenly spaced, the slope is uniform, meaning the incline remains consistent. Next, closely spaced contour lines indicate a steep slope, a wall, or even a cliff. When these tight lines appear at the top of a hill, they point to a sharply pointed hilltop. On the other hand, widely spaced contour lines suggest a gentle slope, where elevation changes gradually. If those wide spaces are at the top of a hill, it means the hilltop is relatively flat. Contour lines in a U-shaped pattern indicate rounded gullies, and V-shaped lines indicate sharp valleys and gullies. The closed end of the contour line, U or V, always points upstream or toward high ground. Conversely, contour lines in a pattern of V's and Is pointing downhill indicate ridges and spurs. A ridge is a sloping line of high ground. The centerline of a ridge typically has low ground on 3 sides and high ground on 1, with varying degrees of slope. Finally, a cliff is a vertical or nearly vertical feature that abruptly changes the land. When a slope is so steep that the contour lines converge into one, carrying contour of contours, this last contour line has tick marks pointing toward low ground. Cliffs are also shown by contour lines very close together and, in some cases, touching. By learning to recognize these patterns, you can visualize the terrain and navigate with greater confidence and accuracy. As we continue exploring topographic maps, let's take a moment to understand 2 important elevation markers, benchmarks and spot elevations. Benchmarks are highly accurate points of known elevation. On the map, they're marked with a black X, accompanied by a specific elevation value. These are often established through precise surveying and serve as reliable reference points for navigation and mapping. Spot elevations, on the other hand, are shown as small dots. While they also indicate elevation, they're generally less accurate than benchmarks. You'll commonly find them at road junctions, hilltops, or other prominent terrain features where exact elevation isn't critical but still useful. In the image, the location marked by X and labeled BM 6893 is a benchmark. The 6833 is a spot elevation for the location marked by the dot on that hilltop. The 6733 is a spot elevation for the road intersection. Recognizing these symbols helps you quickly identify elevation reference points on your map, adding another layer of detail to your terrain analysis. Contour lines aren't just map features, they're mission-critical tools. Whether you're conducting land navigation during training or operating in unfamiliar terrain, understanding contour lines gives you the tactical edge. They help you assess elevation, identify terrain features, and plan routes that support speed, safety, and strategic movement. In the field, terrain awareness can mean the difference between success and setback. So take the time to master these skills, apply them with precision, and always navigate with purpose. Stay sharp, stay focused, and keep moving forward.